I wonder why I didn't press record just now. Whether I just had it on standby, I didn't press record, I wonder. Okay, so there we've got it from the medulla oblongata down towards the bottom of the lumbar region. Okay, and let me go back one. And what you can see is these spinal nerves. So the little spinal nerves there, they're paired. So if there's one on one side, there's one on the other side, etc. Okay, and we'll talk about the spinal nerves just now. Okay, if one takes a section through the spinal cord, so here what you've got is you've got the meninges. Just as you've got the meninges going around the brain, the meninges around the spinal cord, but I've mentioned that 1,000 times now, so I'm over that. This is the central canal. It's a little canal that runs all the way down the center of the spinal cord, and remember that that is connected to and continuous with the fourth ventricle in the brain. And so the cerebrospinal fluid that is in that central canal is the same cerebrospinal fluid that is in ventricle 1 and 2 and 3 and 4. And it just continues down through the center of that. Okay, now I've written here, don't learn all the labeled parts. The reason why I've put this picture in is to show you that there's a deep groove posteriorly and a slightly shallower, wider groove ventrally. So remember that this is towards the person's back and this is towards the person's stomach. So a deep, narrow groove posteriorly and a wider, shallower groove ventrally. Okay, what you can see very nicely here is the spinal nerves. Okay, so this is a mixed spinal nerve because it's got two kinds of neurons in it. It's got sensory unipolar neurons bringing impulses towards the spinal cord, and then multipolar motor neurons taking impulses away from the spinal cord towards an effector organ. Okay. Sure?
Yes, ma'am.
You guys? You've muted yourselves again, haven't you? Okay, right. Oh. Okay. What you can also see in that picture, now I've got to go back to that picture, okay, is you can see that there's two kinds of matter in the spinal cord. Just as there's two kinds of matter in the brain, there's grey matter and there's white matter. But remember that in the brain, the grey matter is on the outside and the white matter is on the inside. Here, the grey matter is on the inside and the white matter is on the outside. So now you've got to understand this carefully. This is a spinal cord. There are neurons which run on this plane. Okay, they're going that way. And those are the ones that form the grey matter inside the spinal cord. So they're going in and they're going around and then neurons are going out. So there are lots of cell bodies at that point, and that's the grey matter. Then towards the outside of those, there are neurons which transmit impulses up towards the brain and transmit impulses down from the brain. And remember that the longest part of a neuron is the axon with the myelin sheath, and the myelin sheath is fatty, and therefore that is white matter. So what you're seeing is there's white matter around the outside, and that's neurons going up and down from the brain, and there is grey matter towards the inside, and that is the neurons that lie on that plane. Okay, right, ladies, are you listening? Okay, right. Okay, right, and this shows you exactly that. So what it's showing you is that these mixed spinal nerves are made up of sensory unipolar neurons that transmit impulses in towards the spinal cord, In the spinal cord, they connect with interneurons in here, and then here are motor, multipolar neurons transmitting impulses out from the spinal cord. So those are the neurons that lie on this plane, okay? And because, therefore, there are lots of cell bodies here, that is grey matter. And then this white matter is the axons of neurons which are transmitting impulses up towards the brain and transmitting impulses down from the brain. Okay, right. So there's a lot of detail of the structure of the spinal cord that you don't have to learn. So just look at the detail in the notes and the text in this PowerPoint. Did you ever get notes?
Which notes?
On the nervous system. Okay. Well, yeah, then it just carries on with that. Yeah, absolutely. Okay. All right. So then what this shows you nicely is if one took some of these vertebrae out and looked at them in more detail, this is what you would see. You would see that the spinal cord runs up or down, doesn't matter, through the central canal, through the neural canal of those vertebrae. And that between two vertebrae, so here's one vertebra, there's the next, there's one of those little spinal nerves, and there's one of those little spinal nerves, and then there's another one on the outside. So spinal nerves enter or leave on both sides of the spinal cord, and each spinal nerve passes through the space between two adjacent vertebrae. Spinal nerves connect the central nervous system to different parts of the body. And I'm sure that you've all heard about somebody getting a slipped disc. It's actually not actually a slipped disc, it's a herniated disc. And that's when this little disc between two vertebrae starts bulging out. And when it bulges out, it puts pressure on the nerve. And that's incredibly painful. And that's what they call a slipped disc, and apparently it's very, very sore. Okay. So spinal nerves are mixed nerves. And when I spoke about nerves, I said to you that nerves are sensory, that transmit impulses from sense organs towards the central nervous system, or they can be motor, in which case they're transmitting impulses from the central nervous system to an effector organ, or they can be mixed nerves. So a mixed nerve is like a two-way street. It's got neurons transmitting impulses in one direction, and it's got multipolar neurons transmitting impulses in the other direction. So spinal nerves are mixed nerves because they're really, really big nerves, and they're made of sensory neurons and motor neurons. And remember that sensory neurons are always unipolar, and motor neurons are always multipolar. Oh, that's spelling error. Sorry, take out P there. Okay. So I just need to go back to this drawing. Okay. So if you look at this spinal nerve here, this is a mixed nerve. It's got sensory neurons, which are unipolar, transmitting impulses in this direction, and it's got multipolar motor neurons transmitting impulses in that direction. And here, where it splits, it becomes a single-lane road. So this side is all the sensory neurons only transmitting impulses there. And this branch is all the multipolar motor neurons transmitting impulses away from the spinal cord. So this is a double-lane road. It's got impulses going this way and impulses going that way. But at this split here, all the sensory neurons are here, and all the motor neurons and multipolar neurons are there. Okay, so this is called the dorsal root, and this is called the ventral root. Okay, dorsal root and ventral root. And then this is just a mixed spinal nerve. Does that make sense?
Yes,
Okay. Right. Okay. What you can see here is on the dorsal root, just outside the spinal cord, there's a big bulge there and a big bulge there. And that is called the dorsal root ganglion. The dorsal root ganglion. And there's one in each dorsal root. And that dorsal root ganglion, do you remember the sensory neurons in there? Oh, flatten. Okay. Okay. So remember that sensory neurons are unipolar neurons. So I'm just going to come over here to remind you. I hope you can see them all there. Tell me if you can't, guys. So sensory neurons are unipolar neurons. Remember, all the dendrites join together and form one dendron. And then there's the cell body, and there's the axon, and there are the terminal branches. Okay, there's Schwann cells. They haven't drawn, but they're there. Okay, so if one had to put this little sensory neuron into that nerve there, what will happen is these dendrites are right wherever the sense organ was. So if I'm talking about, I put my finger on the hot plate of a stove and I get burnt, then these dendrites are actually in my finger. Okay, so there's my nail, and these dendrites are in my finger, and the dendron goes all the way up my arm, and it goes all the way into my back. And it's one long neuron. And then here's the cell body, and there's the axon going into the spinal cord, and there are the terminal branches. Can you guys see this, or is it off the screen?
It's off the screen.
You're a bunch of nanas. Should have told me that long ago. Now. Okay.
Yeah, that's good. Thank you.
Okay. Okay. So, going back to, if I burn my finger, what did I do? I put it over a hot candle or something. I don't know, for whatever reason. Okay. These are the dendrites of the sensory neuron in my finger. They all join together and form the dendron, which is incredibly long. It goes all the way up my arm, and it goes into my back, and here's my spinal cord. Okay? Just outside my spinal cord, there's the cell body of the sensory neuron. So that little cell body is just outside the spinal cord. And then the axon goes into the spinal cord, and it synapses with an interneuron in the spinal cord, which synapses with the motor neuron, which transmits an impulse out to a muscle in my arm, which says, "You're an idiot, pick your finger off of that candle." Okay, so there are 3 neurons involved in this loop. There's the sensory, and remember it goes into the dorsal root. So this is all part of a mixed spinal nerve. dorsal root. And here's that big bulge. The big bulge is there, that dorsal root ganglion, because all of those little sensory unipolar neurons in this big nerve have their cell body there, and that's why there's a bulge there. That's why there's the dorsal root ganglion there. There's the cell body in the dorsal root ganglion. Okay. Then here it goes into the spinal cord. Okay. And so that's grey matter in the spinal cord. So this is grey, and this is white. And that's white, and this is white. Okay? So it synapses in the spinal cord with an interneuron, and it synapses, that synapses with a motor neuron going out of the spinal cord, and that goes to a muscle which pulls my arm away from whatever stupid thing I did over there. Okay. This root here I'm talking about R-O-U-T-E, is what is known as a reflex arc. Okay. I'm going to show you on this picture. So, let's say somebody touched something over there. I've got to turn this back. Sorry, guys. Okay. So let's say in this case it's a foot. Okay. So let's say I stepped on a thorn. So over here would be my foot. And I stepped on a thorn, and the impulse will go through a sensory neuron from my foot all the way into the spinal cord. Here is the dorsal root ganglion, the little swelling, and the sensory neuron then goes into the spinal cord and synapses with an interneuron in the spinal cord, which synapses with a motor neuron. And the motor neuron comes out here, and it'll go to a muscle in my foot and say, pick up my foot, because I've now stood on a thorn. So that pathway that has got those 3 neurons in it is called a reflex arc. A reflex arc. And it's very, very quick. It enables the body to do protective responses very, very quickly without thinking about it. So you know very often you do something like step on a thorn and you pick your foot up and you don't even think about it, and you actually haven't even felt the thorn. I don't know how many of you bath versus shower. But quite often when you bath, you put your foot in the bath and then discover it's so hot, but you don't even feel it's hot. You've taken your foot out of the bath before you even realize it's hot. So you take your foot out and then only do you feel that it's actually really hot. And that's what reflex actions do. They're really, really quick, and they're very protective in function, and they don't involve any thought. I just need to switch off the camera, guys, and start it again.